Everyone. So have you ever just looked up at the night sky and thought about how incredibly perfect it all seems? The planets just cruising along in their orbits, the moon just hanging out up there? It feels like a miracle. And you know what? A lot of physicists would actually agree with you. Today, we're going to dig into why the amazing stability of our solar system is one of the biggest, most fascinating puzzles in all of science.
All right, let's just jump right in. Our solar system is a miracle. It shouldn't exist. I mean, wow, that is a huge statement, right? It sounds like the opening line of a sci-fi movie, but it's actually a real problem for physicists. The fact that our little corner of the universe has been so orderly for so long, it just doesn't line up with what our best theories say should happen. So let's unpack why it's seen as such an impossible long shot.
So that brings us to our first section, a miracle of coincidence, the problem with everything being just right. And this is the big question, isn't it? Is this perfect balance we see just a bunch of super lucky coincidences? Did we just win the cosmic lottery? Or is there something more going on here, something fundamental that we haven't figured out yet?
Okay, let's start with something super simple. A question I bet every single one of us has asked at some point. Why doesn't the moon fall down? And yeah, the simple answer is, well, it's moving sideways fast enough to constantly miss the Earth. But that simple answer just leads to a way bigger, much tougher question. Why was its speed so perfectly balanced in the first place? And if you look at the standard explanations for how our solar system works, you start to see this really weird pattern. For the moon's stable orbit, its initial speed was just right. For all those amazing planetary resonances, well, that was just a coincidence. And for 4.6 billion years of stability, that was a miraculously stable starting point. You see what's happening here? For a scientist, having to say it was just a coincidence over and over again, that's a huge red flag. It's like a warning light telling you that maybe, just maybe, your theory is missing a piece.
And here it is, the mathematical nail in the coffin. It's called the three-body problem, and it's been a headache for physicists for like 300 years. The idea is simple. You can perfectly calculate the orbit of two things, like the Earth and the Sun, no problem. But the moment you add a third object, say Jupiter, everything goes haywire. The whole system becomes chaotic and unpredictable. So the question is, if three bodies are a recipe for chaos, how in the world is our solar system, with 8 planets and a ton of moons, so ridiculously stable?
All right, so if the answer isn't we got really, really lucky, then what is it? Well, let's look at a totally new way of thinking about space itself, with a new theory called Hyperbrane Relativity. The basic idea here is that maybe we've been looking at the puzzle with a piece missing. And here is the absolute core of that new idea. In standard physics, right, we have 3 dimensions of space, up/down, left/right, forward/back, plus 1 dimension of time. But hyperbrane relativity, or HBR, it completely flips that on its head. It says, what if there are 4 dimensions of pure space? And what we think of as time is actually just our whole 3D universe moving through that 4th spatial dimension. It's a huge shift in how we see everything. So what is this 4th dimension? Well, they call it the W-axis. Now, you can't point in the direction of the W-axis. It's not like north or south. Think of it more as a dimension of scale. It's a fundamental direction that governs the size of things, from tiny quantum particles all the way up to galaxies. And adding this one extra dimension has absolutely massive implications for how things like gravity and orbits behave. Okay, so let's get to the good part. How does adding this one little dimension help us solve a 300-year-old problem and finally tame all that chaos?
Well, in this new 4D space, you get a few new rules for how forces work. First, you've still got gravity, pulling everything together just like we're used to. But then you get this short-range force called vortex repulsion that basically keeps things from crashing into each other. And then, and this is the really big one, you get something called W-axis tension, a long-range force that acts like a cosmic leash.
Yeah, this W-axis tension, it's like a giant cosmic fence around the whole solar system. Remember the 3-body problem, where one planet can just get yeeted out into deep space? Well, with this tension, that can't happen. Everything is sort of tethered to the center of the system. Orbits can still wiggle and wobble, for sure, but they can't just fly off into oblivion. The chaos is contained.
And get this isn't just a cool thought experiment. They've run the simulations. When you plug these HBR forces into a chaotic 3-body system, the amount of chaos drops by an incredible 87%. Now, the way they measure chaos is with something called the Leonopov exponent, which is basically just a number that tells you how unpredictable a system is. So, an 87% drop is massive. It means the system basically forces itself to become stable and orderly.
All right, now let's talk about the star witness for this whole idea. The best piece of evidence we have might be hanging right up there in our sky every single night. Let's talk about the moon and how it acts like our planet's personal shock absorber.
I love this quote. The moon is not just a companion, it is Earth's shock absorber. And that's exactly what HBR theory suggests. The moon isn't just there, it's actively doing a job. It's working as a giant damper, absorbing energy to keep our own planet stable.
And you know what? We can actually see this happening. We have the data. We know for a fact that the Earth's rotation is slowing down just a tiny bit, about 1.7 milliseconds every century. And at the same time, we know the moon is drifting away from us by about 3.8 centimeters a year. Now, those aren't two different things. They are two sides of the same coin. The Earth is transferring its rotational energy to the moon, and that's what's stabilizing our spin and our climate.
Okay, and this is where it gets really cool, because HBR makes a specific, testable prediction. The theory says this whole locking mechanism depends on the mass ratio between the planet and its moon. If the ratio is really big, like the Earth and Moon at 81:1, you'll get a one-way lock, where only the moon is locked. But if the ratio is much smaller, like around 8:1, you should get a mutual lock, where both bodies are locked to each other. So we look out at Pluto and its moon Charon, and what do we find? Their mass ratio is about 8:1, and guess what? They are both tidally locked, permanently facing each other. The prediction works perfectly.
So what does this all mean for us? It means that our stable climate, the thing that allowed life to even get started and thrive here, it might not be a fluke. It might not be a lucky accident at all. It could be the natural, predictable result of simple geometry. The geometry of a planet and a moon having just the right mass ratio to create a stable system. Our existence might be written into the math.
Okay, so this whole idea of self-organizing systems, it's not just about us and the moon. Let's zoom out and see how this changes the way we look at the entire solar system, from chaos to cosmos. So in HBR, stable orbits aren't just random paths that happen to work out. They're called attractors, and the best way to think about this is to picture a big bowl. If you toss a bunch of marbles in, they don't just land and stick anywhere, right? They roll around and eventually all settle at the very bottom, the most stable, lowest energy spot. HBR says that's what orbits do over billions of years. They naturally find these attractor states.
And we see these attractors all over the place. Look at Jupiter's moons. For every one orbit Ganymede makes, Europa makes 2, and Io makes 4, a perfect 1-2-4 resonance. Or look at Neptune and Pluto, a 3-2 resonance. We even see this in other star systems, like the amazing TRAPPIST-1. These beautiful mathematical patterns aren't coincidences. They're the marbles settling at the bottom of the bowl. It's the system finding its most stable, peaceful state.
So this brings us back to our original question. Miracle or geometry? It really offers a whole new perspective on the universe.
So here's the choice. The old view basically says our solar system is a frozen accident. We're here because of an incredible string of lucky breaks. It's a universe of pure chance. But the HBR view, it suggests our solar system is a self-organized system. Its stability isn't luck. It's a predictable result of 4D geometry. We're not an accident. We're an expected outcome of the laws of physics.
And this quote from Yuichi Yamamoto, who developed the theory, just nails it. The universe doesn't need dark matter. It needs the right geometry. Think about that. What if the solution to some of the biggest puzzles in cosmology isn't some new, invisible particle we have to hunt for? What if the answer has been right in front of us the whole time, hidden in the very shape of space itself?
So I'll just leave you with that to think about. What if all the things we see in the cosmos that look like miracles aren't miracles at all? What if they're just the result of a simple, elegant geometry that we're only just beginning to understand? It makes you wonder, what other cosmic mysteries are just waiting for us to find the right geometric key?